Is my screen visible?
Yes, sir.
Yeah, okay. So today we will cover, this is from your unit 3 and we have total unit 5 up to unit 5, okay? So in unit 3 this is all about your moving average and exponential smoothing and how we can implement through the Python, okay? And the agenda would be to cover this time series and visualization, and I think visualization is all about how you are trying to explore the data through different visuals. So we will also see performance evolution, and objective means how your time series models are performing. Forecasting tools are nothing but it is just the different types of forecastings, you can say. Smoothing and filtering, it's all about moving average and different techniques, and how we can build this moving average and exponential models that is related with your time series models. So we will see through the Python how we can implement. So if you see this meme, so the during the old times, people used to have some kind of fortune teller kind of a thing. They used to have some documents, you can say, or some non-scientific way of predicting something, okay? During ancient times, okay? So now it's possible to predict a stock prices. So now people are just throwing away those the older stuff. So how over the years we are able to predict, right? It's not easy to predict the future. Now it's a time that we are predicting the future, right? So future prediction, or you can say the forecasting, is now easy because now we have a rich set of data, right? Now we have large volumes of data. We talk of big data analytics because now we have a variety of data, the volume of the data, the veracity of the data, okay? There are different, you can say, the dimensions of big data analytics. So these are the way, and are sophisticated machine learning algorithms. Over the years, the machine learning algorithms are maturing. People are working on it, and finally you are able to come up with certain the nice predictions, which are kind of, you can say, they are touching upon the accuracy which we want, right? So in time series smoothing, in this unit 3, if you see, they are talking about the moving average and different exponential smoothing techniques. So at first place, why this is smoothing is required in time series models, okay? So obviously the time series will have a the x component as a time. If you see on the right side the visuals, you can see the on the x-axis we have a time component, and the y we have the the corresponding values. Maybe it's a sales data, maybe if you have a stock price. So in that case it's on the y, but always in the time series the x will have the time component, okay? So the smoothing in a time series removes certain frequencies or components to gain a view on underlying structure of the time series, okay? So at first place, why we are trying to smooth the the data, right? Why? If we have certain the frequencies to be removed, because ultimately it's a noise, right? So the noise component is creating a problem for your data set. If your data set has a noise, right? So your noise is going to create a problem, and it will create headache for the end predictions. So we want to remove the noise to strengthen the signals in the time series before we begin our analysis, okay? So removing the noise improves our data quality. So whenever you apply machine learning algorithms, if you have a time series data, just check if there is some noise in it or not. So that noise can have an idea through the data visualization techniques. You can visualize the data through different charts and graphs. You can use Excel, okay, and you can see if there is some noise in the data or not, okay. So the data smoothing is basically nothing else. It's averaging the data points with their neighbors in a time series, okay. So that is why you will see majority of the time we are trying to apply the average, the mean values. So how your mean values and the corresponding data are centered around, right? Resulting a blurring shape of edges in our time series. So when you apply these smoothing filters, your edge on the data, right? If you see the visuals, it will blur, right? So in which the high frequencies are suppressed to extract the low frequency signals, okay? So that is why the smoothing is required whenever you apply a time series models, okay? So with this, we generate a new smoother data points for each data points in the time series. Obviously, when you are able to extract the low frequency signals, it will help in the predictions, okay? A new data point is nothing but it's a predicted values, right? And there are different way to achieve this smoothing. The moving average, kernel smoothing, and exponential smoothing. Means we have three types of exponential smoothing: single, double, and triple. But we will see broadly how this exponential smoothing help you out. So just see one by one. The first one is moving average. As I already told you, and I think in unit 1 or 2 there was an introduction to time series, so where I have just explained you the moving average. The average, the average is going to move. For example, 2 months the sales data, 5 months sales data, 10 months sales data. It's all about moving average. We are just averaging it out to predict a new sales value after 2 months. That is your moving average, okay. So moving average in approach, we typically use something called a sliding window of a fixed length. If you see on the right side, this is a sliding window, right? Of this is certain filters, maybe 2 by 2 filters. You might have seen, or the people who have a knowledge of this computer vision, in that case we do use some filters, 2 by 2, 4 by 4, 16 cross 16. So these are the some filters, and we move it, okay. So the approach is well suited for the data with little noise and to highlight the long-term trends. So if your data have a little noise, okay, in that case this moving average with this small filters can help you out, okay. However, the moving average cannot capture the seasonality and thus should not be used for time series and seasonality and complex non-linearity, okay. So moving average typically it doesn't capture the seasonality. Seasonality means if there is some the peak value at certain months or not. For example, during some festive seasons, okay. So the sales of certain goods it picks up, okay. For example, during Dasara, certain items move speedily, right? So you will see every year there is a peak around that month, right? So the approach cannot calculate the value at the start or at the end time series depending on whether one-sided or two-sided moving average, okay. So the sliding window is put around the data, and the value within the windows are averaged before the window is slide to the next data point. So I'll show you one video how this sliding window works. So just see this this video. If I have 1 minute, just one. This one, I think. Not this one. This one. So this is your sliding window. They have certain 2 by 2 you can say, or 4 by 4. This is moving, okay, with the fixed length. It has a fixed length and it is moving over time, okay. So this is one of the example of moving average with sliding window. If you see the red part, this is smoothing, okay, and this is a predicted value. You can say the smoothed value, that is your, this red part is a smoothed value. You will see whenever this this window is, this frame is moving, this window, the smoothed part is coming, okay. So this is how moving average works. So this is all about your moving average. Now let's see. And this moving average, the depending on how the sliding window is placed around the data. So okay, so the moving average is, if you see this part, this has a left and a right part. So this is a two-sided, have a right and left, and sometimes we do use a left part also, okay. So the point is, moving average is typically it just averages the data points, and it helps you try to extract the low frequency values. So these are just a formula, but how it works you have seen it, and this value is just the predicted value, okay. So whenever you see any time series data, maybe some stocks data, some stock prediction, you will see how the moving average, it takes the value of moving average and it will predict you, okay. So I'll also show you through uh, the stock price, how you are going to predict the stock, right? So now coming to this kernel smoothing, it's a lot of little maths is there, but I'll let you know some the, you can say, the trick how to check the kernel smoothing. It's similar to this moving average. The only difference is that we use different weights for averaging the sliding. The weights depend on the shape of the kernel function. So if you see, this is the shape of a kernel function and it will also move, okay. So this kernel, if you see this kernel function and just see the formula, the Gaussian formula, 1 divided by sigma root 2 pi and exponential of x minus x bar divided by 2 sigma. This is just a mean value, okay. Don't go with the maths, just see their shape, okay. If you see this one, this is similar to the something called what you call standard normal distribution or normal distribution. So if you see this shape, it is a normally distributed data is normally distributed because there is a peak, okay, and your data, maximum data is centered around center. So it's a normally distribution. So Gaussian is nothing but it's a normally distributed data, okay. The difference is only with this kernel and this moving averages depending on the weights. It has just they have added the weights, and then they have this sliding window of certain width and height, and you can move it and it will predict it, okay. This is a smoothed value, okay. So this is kernel smoothing. If you see this exponential smoothing, okay, in this exponential smoothing, the term exponential means it will have some exponential component, e to the power some x, okay, and this is also a filter value. So if you see this right side, this is a filter, one of the filter, and we will move in this direction, okay. So the moving average and kernel smoothing cannot capture a complex non-linearity and cannot calculate the value at the start and the end of the time series, okay. That is why this exponential smoothing was developed. If you see any the forecasting techniques, the end and a start point, it's very problematic, okay. So that is why this exponential smoothing was developed, and the all past observations are weighted based on exponentially decreasing function. If you see this shape, this is exponentially decreasing, the value is decreasing, okay, and you will slide the window because sliding windows will give the smoothed value, that is your predicted one, okay. That is where you are just sliding it over the data because this is a historical data, all are historical data. If you move from here, it is futuristic data. So that is why we whenever we are moving the filters, it is giving us the predicted value. around every single values. Okay, so no sliding window is used, and the more recent data points are given a greater weights than the one that is further past. So the obviously if you see this time series data, there is alpha, it is always 1 minus t and multiplied by alpha if you see the formula. Okay, so alpha is coming from this this exponential smoothing, this factor. So similar to this moving average and kernel smoothing, the challenging point is that to choose the right smoothing factor, where it is written the smoothing factor, that is 1 minus t multiplied by alpha. Okay, and there is something called a hyperparameter. So this alpha is nothing but it's a hyperparameter. Hyperparameter is like for example, if you are developing, let's say, a machine learning algorithms for predicting, let's say, sales value, we have, let's say, 10 years of a data. So when you train and test your model, maybe if their accuracy is, let's say, 75%, let's say, okay, when you tested, the test accuracy is, let's say, 75%. Okay, now your manager wants to, they have given you the instructions that you just want to, increase the, the performance, okay, the accuracy. So how you are going to increase it? So in that case, this the hyper parameter, you're just trying to tune the, the model. Tuning means it's like for example, if you have FM, so whenever you find a problem with the, the sounds, okay, and the frequency, you just try to tune it, the fine tuning. So hyper parameter is like a fine tuning your model. So whenever you just give certain parameters to the machine learning algorithms, for example, in time series it's alpha, you're just fine tuning it. So whenever you just providing some value of alpha, maybe you just test and trial. So in that case, your model may give you the accuracy higher or it may lessen. So it depends on fine tuning the hyper parameters. Okay, so we can choose the different three types of this is exponential smoothing, that is a single, double and triple exponential smoothing, but I'm not explaining this one. If you see, there is one more video, just see so that you can have at least you remember it, that how this sliding, the filters work in case of exponential smoothing. And just see this one. So this is sliding, okay, and this is a decreasing value, that is a, if you write any exponential function, this is a decreasing exponential function. Okay, that is why their shape is like this. Okay, and this is moving the smoothest value, so they are predicting it. Okay, this is the actual one and this is predicted one, that is why it's a predicting, and they have predicted the futures of this one. Okay, that is why using this sliding window, this sliding functions, the time series model, they through the historical data they predicted. So that is why this smoothing factor, and this is also a hyperparameter, means whenever you try to fine tune the model, you use this hyperparameter, and this works like this. So when you run your machine learning time series model, the internal structures mathematically works like this. Okay? So that at least you can remember. That is why I just run it. So now just have a look. Okay, so we have seen this exponential smoothing. Now we will use this moving average. So how this moving average, and this exponential model can be used through Python. So we will implement it through Python. So first see the data set of for exponential smoothing and moving average. This is your Reliance data set. It's a stock price. Okay, open, high, low, close, adjacent, close, and volume. These are some of the stock price, and we have this Reliance stock price. So now how we are going to apply and this will have the prediction and all. So whenever anybody working on this time series models, for example for your project and all, your data set looks like this. So the typical the business objective is to predict the forecast your the stock price. So what will be the stock price in 1 month, 2 month, 3 months, maybe at certain dates. So this will help you, and the basic idea behind this time series model is obviously the moving average and exponential smoothing. So but at the center, the core idea is always the moving average, because they will use certain these sliding windows to predict. Okay, they will use some alpha. Obviously the alpha can be calculated through this data set only, the historical data. It will only, the model will give you the alpha value. Okay, so uh, just see. So I have shown you the data set. So data set, just maybe, okay. So we have this library pandas pd, we have seen it. So for importing, for mathematical calculation we are using this numpy, and for matplotlib is for if you want to plot some graphs charts. Okay, that is why. So if we run it, we have obviously this is running, a star marks means running. Now it has already executed. The second line, this is a Reliance stock. So this is user defined. We are reading the CSV CSV. So the data set is here. It's saved in my local this laptop. Date, and we are parsing the date is true. So now we are running it. So when you run it, it will give you some commentary like this. So don't get confused. It's just a commentary, and the data set is here. Okay, open, high, low, close, assembly. This is just displaying whatever in this data set. Okay, in the Excel you have seen it. Okay, now this SMA means simple moving average, and the window size is 30 cross 30, the one which I have shown you, the window size, the sliding window. Okay, the close to frame, this is just the command, the close value, and rolling 30, and the mean is centered around, that is why in the mean value, as I already told you. And you have to drop, if there is no any value, then you have to drop, and then printing the data frame. So it will print values. Just see, close, and this the closing values and their corresponding simple moving average. Okay, this is simple moving average. So 2399 was the value, or you can say the exact value of it was there, but the predicted one 2642, that is simple moving average, with the sliding window value is 30. Okay, so this will give you a chart. Okay, the actual value and the predicted one. Okay, the closing. Similarly, how we are going to plot? So through matplotlib. So the closing value, let's say, is here, and their simple moving average value, the predicted one was this. Okay, so this is historical data, all blue is historical data, but the yellow one is predicted one, that is simple moving average of the window size 30. Okay, so this give us an idea. You can have, by looking at this time series, the visual, you can have an idea whether your actual and predicted value are coinciding or not. At least you will have an idea that how much fluctuation is there. Okay, if you will see, there is a less fluctuation, but here there is a problem. Okay, here we have little bit quite good here up to here, but here is a problem. So we have only few data points, that is problematic. But if you see holistically, we will see the accuracy is quite good by looking only through these visuals. Okay, so that is why data visualization is more important, because it will give you a lot of informations before going to the mathematical calculations. Because when you see some mathematical equation we hardly understand, but visuals tell you the more story, right? So now now we are implementing this exponential moving average. Here we have implemented only the simple moving average here. Now we are just implementing the exponential smoothing. So this panda library is numpy is same, this all coding is same here. Okay, now the data set, we are just importing the data set, it's also similar, so we will run it. Okay, so if I just scroll it down, there's the same data points here. Now the close and also their window size is 30, we are just taking 30 and we are just saying the mean value averaging. So obviously whenever you are just doing a smoothing, we are just averaging it out, that is a mean value. Okay, so now let me run it. When I run it, just see 2622 was the closing point, and 2622, if you see this exponential smooth, it's a very close. Here also just see 266 and 3 2650, it's also very close. So when I applied this exponential smoothing of window size sliding window 30, you see the actual value and the predicted value are quite close. Okay, now we are just displaying it through visuals. So just let me display it. Yeah, just see their difference is less compared to moving average, and if you see the data points are they are coinciding it with the actual and predicted value. Okay, so that is why we are using exponential smoothing. Okay, the of that window size maybe 30, you can take 20 just to check how much accuracy this is giving. So that is why if you compare with simple moving average with the exponential smoothing, you will see that there is a contrast. You will see that their accuracy is quite good. Okay, that is why just go with the exponential smoothing if you have a large data set. If you have a small data set, you can manage with the simple moving average because it will not create that much problem. Because if you have a large data set, it's good that you give machine the large volume of training data so that they can train well, and just apply 10 or 15% of the testing data, the unseen data, then how they are reading the data. Okay, how well they have learned from the machine learning models. So this will give you more accuracy. So I'll always tell you to go with this exponential smoothing if you have a large data set. Okay, so this is how you can implement. Just see their value and this exponential smoothing. There is a large gap here, but when you apply this exponential smoothing, the gap has reduced. Okay, so this through visuals you can have a look. Okay, so this is how we have implemented, and that's it. This was our data set. So typically in time series, if you see the stock price, you will have this rows like this: open, high, low, close, adjacent, close, and volume. So this kind of the columns you will typically see, and this date. Okay, obviously for time series, obviously date will be there. Okay, this is how we can import the data set. And for a simple moving average of window 30, we have just seen how it has predicted. Okay, there is some the actual and predicted value has some gaps, but they are also giving some pretty cool this accuracy. Okay, and this is visuals, the data points and their predicted value. Okay, so and this one is our for obviously for exponential moving average, the same coding is here just to display the data set here. And the command which we have used, the close, you can also use for open and all this, and you can check how they have predicted. And exponential, the weight, this one, the span of 30, it means that the window size, and we are just means averaging it out. And these are the predicted value, and this is our actual value. If you see their difference, you will see a difference is not much. Okay, So you can compare, let's say 2672 and it is saying 2648. So not that much difference. And when you see holistically, the exponential smoothing will give you more accurate result, because it uses the exponential functions. Mathematically, the exponential functions, they typically reduce the error. The exponential functions will reduce the error. That is why it is preferred to use this exponential smoothing. Okay, and for practical purpose, you can also reduce the frame. If you put a large window size, your accuracy is going to increase. So you can also increase to, let's say here is 30, just check with 40 and 50. If their accuracy is high, then it will just I think hypothesis will be proved. So just try checking with larger window size, okay, whether the accuracy is getting higher or not. Okay, so as I already told you, with simple moving average and this exponential smoothing, we have seen the accuracy is higher. Okay, and our visuals is also telling the same story. Okay, so this is all from my side. Okay, so if you have any question, you can ask. Arif, are you there?
Yes, sir.
Just take attendance. If you have any question, you can ask, and I will upload it. Okay, and you just run the today's this time series model, because it will help you to understand it. It's a simple one.
Sir, I am taking the screenshot.
Okay, just send me. Okay, so when is your last class, Arif? Can you have that? Do you have this calendar? If you have of last class, can you tell me in May, or it will go in a June also?
So we are not been told about the last class right now, but
Can you
the
give
last,
at least an idea,
so it
because
will be around 30th April, I guess, up till this month. Tentatively, I will confirm it and let you know.
only 30th?
Yes, sir, most probably.
30th, how we are going to learn? Then I have to speed up. uh, there is a no class in May. What?
Sir, we'll discuss it with ma'am, with Varsha ma'am, and we'll let you know about it.
Okay, Saloni.
And sir, wanted to ask one more thing, sir.
Mhm.
Will it the practical exam? It will be online or it will be like the offline exam?
I think you people must ask, because maybe I think online or offline, in which
Sir, we
mode
are
you want it?
actually studying it online. So if Varsha ma'am asks you about the mode, could you please make it online because ma'am is going to eventually ask it from you. Ask the mode. So if you could make it
Okay.
online, then it will be very easier because the last semester as well, we when we had like an online subject, the predictive analysis subject, the exam was also online. So it will be very helpful if you could just ask ma'am to conduct the exam online.
Okay, and I'll
And we'll
put
talk to
forward
ma'am.
this thought. Hmm.
And yes, sir. And we'll talk to ma'am and we'll let you know about the last few,
Just
like
tell
the
me.
predictive
Yeah,
analysis.
that is more important, because there are two more units, and
Yes, sir. Yes, sir.
maybe I can easily cover, but I don't want to cover in that mode,
Okay,
because
sir.
I
Okay,
just
sir.
okay.
Sir, I'll coordinate with ma'am and we'll let you know in the group.
Yeah, just tell me, because it's
Okay, sir.
swinging only two three classes, so
Yes,
it's
sir.
very
Yes, sir. We'll do
difficult.
that. I'll do that.
Okay, thank you everyone.
Thank you, sir.
So meet you in the next class. Okay.
Thank you, sir.